Okay, so I promised you guys an update here. So here's where I'm at. So I started with 20 by 20 extrusion aluminum. Got it all squared up. Got the y-axis 20 by 20 straight, square with the face, parallel with each other, and flat with each other. Then I added the bottom, which is a 1-inch MDF. You can see the underside here. Yeah, that's just all bolted on with, bolts through. And can't really see underneath, but the 3D printed part there for the bearing. I got an MDF for the plate. I made these thrust bearings. So this is like 2 flat washers with the needle bearing in between, and then I 3D printed a cover for it, like a dust cover, to keep it all oriented and centered. These are ball screws on all 3 axes. Decided to mount the linear rails on the side. I have to finish the Z yet. Right now I have a pencil, kind of mimicking a spindle. So I have a faceplate and a motor mounted here. This is a C-beam rail that I bought from Open Builds. Works pretty good. They're nice and straight within a thou, and they're pretty durable. Then again, for here the same thing. I have a 3D printed mount for the bushing there that's attached to this 3D printed part, which for my Z-axis. This is another C-beam with the rail mounted to it. From the back side here, this is for the y-axis. So this is a 3D printed mount. The coupler is 3D printed. I have my thrust bearing. Then I have another bushing block and another thrust bearing back here. And that's the same on all 3 axes. Alright, so for the control, so as you can see, I'm not using the 3018 standard board. This is a Mach 3 board. I'm originally going to set this up with 5 axis. So the plan is to have a rotary trunnion that I'm going to custom build for this, which explains why I have all this height in here. Standard stepper motors. Got a 24 volt power supply. Fused, of course, always be safe. Main power switch. And one thing I wanted to show you is I started putting these ferrules on these wires, and boy, these things are a lifesaver. I don't really promote products, but I bought this assortment off Amazon for like 10 bucks, and they're worth every penny. You get one little straggler wire, really messes things up. Anyway, so I'm running Mach 3 on this. I'll give you a quick mock-up of my demo here. So have it cutting a 100 millimeter diameter circle. So what I find surprising in this, these are 12 millimeter ball screws with a 4 millimeter lead. These stepper motors, they're NEMA 17s. I got them from, if you had this up right. I got these from Stepper Online. It's a nice source for stepper motors and drivers. If you notice, they're a little taller. So I think these have 59 nanometers of pull. What I find really surprising with these guys is, one, with these rails, I have there's no flex in this guy at all. You know, I'm literally moving this whole machine. No twist in the x-axis, and if I grab this Z spindle down here at the bottom, there is like zero flex in this guy. Also, what was very surprising to me was with these NEMA 17s, they're just slightly stronger than the standard NEMA 17 that you see on the 3018 CNC. But I couldn't stall this thing. I was just kind of trying to jam things in here, trying to hold the table while it was going. Here, I'll start it again. So I am really pushing on this thing. See, I'm like white knuckling it, and I can't get it to stall or skip a step. Same thing on the x-axis here. Like, I think it would literally break my fingers if I let them get wedged in there. So this thing's going to be a beast. Until next time.